So some of you may have gotten a little note on your quiz, a little comment from me that maybe said something like this, plus, minus, just as a reminder. On the quiz, there was an opportunity for you to use a square root, and that's one of the times you have to remember a plus minus. So there are two times in math that a plus minus is always required. The first one is whenever you use a square root. If you use a square root in your problem, whether it's the quadratic formula or anything else, whenever you use a square root, there's got to be plus minus. So it's just going to be a reminder all the time. There's a second time that you would use a plus minus. I know, So the second time you're going to use a plus minus is whenever you take away an absolute value. So those are the two times. Often, those are the ones that are forgotten on a test or quiz, and then I have to write the little reminder, plus minus. Don't forget your plus minus. Okay, anytime you use a square root, and anytime you take away an absolute value. So I'm just going to show you how that works in some sample problems as relate to your homework. So these are all solve. Solve means take it all the way to be equal to 0 until you get your final answer. And so we're going to solve 2 that's outside of an absolute value. Inside's going to be x minus 4, and on the opposite side will be 16. So we've got an absolute value. So the process of solving is always taking things away until you have x by itself. So as you look at that question, what should we take away first as we're working towards solving? The 2. How do we take that 2 out of the problem? How do you take it away? Divide. Okay, so we're going to divide everything by 2. That's going to give me x minus 4 equals 8. Now I want to take away the absolute values. And it's legal for me to do that as long as I remember that I need to bring in a plus minus on the other side. So anytime you take away an absolute value, you bring in a plus minus to the opposite side. And then it's just one more step to get x alone. And x would be equal to positive 4 plus or minus 8. And you need to simplify, take it all the way. So 4 plus 8 is going to give me one answer. And 4 minus 8 would give me my second answer. So 12 or negative 4 are the two solutions for this. Now suppose that you have the same exact question and the only difference is that there's an inequality. So you're asked to solve 2 absolute value x minus 4 and there's a less than sign. Well, we already know that the numbers are going to be 12 and negative 4. The solution isn't going to change. But then how you write it on a number line does. So because it's an inequality, we now need to put those numbers on my number line. So we've got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and negative 4. Because the inequality is less than, I have open circles on both of those solutions. Also because it's less than, the less than tells you what kind of shading you're going to do. Less than is always shading between the 2 points. That's always true when the symbol is less than. When the symbol is greater than, then you'll be shading the outside ends instead of the inside ends. So doing the math is remembering the plus minus, and then the inequality makes it a shading problem. So let's look at that in a different question. When we solve the following, 4 absolute value, 3x minus 2, another absolute value, greater than or equal to 20. So this has an absolute value, which means I need to use a plus minus. It also has an inequality, which means I'll need to use a number line. So I've got an absolute value and an inequality to worry about. Let's worry about getting rid of the number 4. We're going to do that first. That's division. So we'll have 3x minus 2 is greater than or equal to the number 5. Now I'm going to take away those absolute values. When I do that, I'll have 3x minus 2 with a plus or minus now on the side with 5. Now you add 2 to both sides. So that's going to give me 2 plus or minus 5, which I should simplify to 7 or negative 3. My last step is to divide by 3. Everything. The x part, the 7 part, and the negative 3, they all get divided. So I have x is greater than or equal to 7/3, or, whoops, wasn't supposed to divide by negative, or negative 1. Now these are both going to go on a number line. 7/3 is between 2 and 3. It's right here, approximately, and negative 1. Now we have to look at our shading. Because this is an equal to, I need to fill both of them in. Because it's greater, you shade 1 to the greater end, but you shade 1 to the opposite side as well. Now, I think that your Algebra 2 teachers, Ms. Price and Ms. Cowie last year, told you about the play on words, the great, oops, like if you see a greater symbol, you have to think great or instead of greater. It's an intentional misspelling of the word greater. Okay, we have less than and great or. So or means you're going opposite. It's either or. It's either to the left or to the right. It's opposite directions. So the answers get written like this. This one is the x greater than or equal to 7/3 because it's going in the greater direction. And it's equal to because it's colored in. The other one, the sign has to flip around. And it's going to be less than because it's going to the left, negative 1. So you need to make sure when you have great or that you have one of each sign. One of them is the greater than sign, the other one is the less than sign for the one that's going to the left. We could also write this in the notation we learned yesterday about intervals. So we could say 7/3 starts at a closed interval and then comma and goes all the way to infinity, which is a soft interval. So that's going 7/3 and going all the way positive. And for the other one, we could have negative 1, and that has the hard bracket because of the closed circle, and it's going all the way to negative infinity on the other side. So you should be able to write it both ways. You should be able to draw it, you should be able to write it with an inequality, and you should be able to write it with an interval, which is the brackets or the parentheses. Okay, a couple more. Anybody have a question on that one? All right, 2 more, I think, and then I feel like we'll be satisfied. So we're going to solve x squared minus x minus 12 less than 0. So in the first couple questions, we were getting rid of the absolute value. This time we got to get rid of the square. How do you get rid of a square? Don't say square root because you'll be embarrassed when you say it because it's not the right thing. How do you get rid of a square? Factoring. Okay, factoring is how you get rid of a square. Okay, not with a square root, but when you've got an x squared and an x and a 12, we're going to factor. So this is going to be a factor problem and a number line problem. Factoring and number line at the same time. So we'll have negative 12 and negative 1 are parts of the factoring star, and so that's going to be negative 4 and positive 3. So when I come back and I'm going to use my factoring, you guys are pretty much very proficient at factoring now. You'll have negative 4x and positive 3x minus 12. You'll double split that so that you can factor out each side, and you'll take out an x from the right side, leaving you with x minus 4, and you'll take a 3 out of the left side, also leaving you with x minus 4. So altogether, x minus 4 and x plus 3, and you set those both equal to 0 because they're factors, and factors always get finished. So finish the factors by setting them equal to 0. So we're going to get positive 4 and negative 3. These are the numbers that go on your number line. 4 and negative 3. So finish the factors, put them on the number line. 1, 2, 3, 4. 1, 2, negative 3. Open or closed circles for this particular question, and make sure you look all the way back at the beginning. Open or closed circles. Why open?
Not equal to.
There's no equal to bar underneath. So we're going to do an open circle for both on the 4 and the 3. And then because the symbol was less than at the beginning, this was a less than problem. Less thans are always shaded between the two. So less thans will always be the ones that are shaded that way. So to write that as an interval solution, we can write it negative 3 less than x up to 4, and we show that we're not including negative or 3 or 4 because it's not a closed circle, so you could write it that way. Or you could replace the x with a comma, and you could have negative 3 and 4 and use parentheses. But again, you remember why I really don't like the parentheses so much? To me, that looks like a point that I'd graph on a grid, but that is the correct way to write it as an interval. All right, final one. Remember, you can't get rid of squares without factoring. You're not just going to throw a square root on there. So we're going to solve as our final one, 2x squared plus 3x greater than or equal to 20. First thing we got to do is pull the 20 over to the other side. So that'll be 2x squared plus 3x, and we're going to pull that 20 over so that it's on the opposite side, so I've got a 0. Now I want to get rid of the square. Best way to get rid of this square is with factoring. Negative 40 and 3. So think about that a little bit. What can I come up with? I heard it. Okay, I've got an 8 and a 5, and it's the 5 that has to be negative to make that work. So we come back, like, all right, 2x squared plus 8x, and then minus 5x minus 20. And we're going to split that so that we can factor it. The left side has the common factor of 2x, leaving me with x plus 4. The right side has the common factor negative 5, leaving me with x plus 4. And I notice that they match. If they don't match, you got to stop. Something's not right. You didn't pick the right star numbers, or something's not right. They should match. So we've got x plus 4 and 2x minus 5. So now finish the factors. Don't just stop at factors, finish them out. So x plus 4 gets set equal to 0. 2x minus 5 gets set equal to 0. So when we finish, we've got negative 4 and 5 divided by 2. Those are the two places that you're going to go now mark on your number line. So a lot of this stuff is the same thing we've been doing. The new part is where we're putting it on the number line and doing the shading that goes with it. So we've got negative 4 on our number line, and we've got 5 halves, which is 2 1/2, so it's between 2 and 3. We'll mark those out. And considering what the symbol was at the beginning, do we or do we not shade these in? We do. Why? Because this isn't equal to, so we're going to shade them. Now we got to consider the direction. What was the original sign of the problem? Greater, which we say is great or. Okay, great or. And so we are going to be shading partially to the right, and we're going to be shading partially to the left. So as we write our answers, we're going to have separate intervals for the two arrows. The arrow on the left will be x less than or equal to -4, less than because it's pointing left. The arrow to the right will be x greater than or equal to 5/2, greater than because it's pointing to the right. And in interval notation, we start it with a hard bracket at 5/2 and show that it goes all the way to positive infinity. In the other interval notation, we'll end it at -4 with a bracket and show that the soft side is on negative infinity. So you should be able to answer your problems in 3 ways: the number line way, the inequality way, and the interval notation way.